All right, third and final part for the scientific method, guys. Part 1, or part 3. God, lost my mind today. Beginning. So, sometimes in science we have to use things known as models, okay? And we use models for really abstract, really big things that we cannot feasibly comprehend. When we in our science class get talking about plate tectonics, that is hard to conceptually grasp, that we are sitting here in Virginia, in North America, on a North American tectonic plate that stretches out halfway through the Atlantic. It's all the same giant rock that we're sitting on. That's hard to grasp. The size and the scale of the Earth, what it's like, is hard to conceptually grasp. To realize how big space is, these things are hard to understand. It's why we go to places like planetariums. We go and see these things displayed out to us so that we can feasibly understand it, because it's so much to try and comprehend. The other type of models that get used in science are models for things that are super duper teeny tiny. All right, you guys all know probably what genes look like and what DNA looks like. Its shape, that idea, the double helix shape, right? But that's so tiny that we've used models to explain that. And the reason why that you guys know it so well what a double helix is at this point is because of all the models that have been put out for things that small. So right here is a model, okay, for a chemical equation, for an atom, for a molecule. Okay, those things are so small. We can't grasp it. But being able to put it in my hands, being able to see it and visualize it and model helps our brains immensely. Now, here's where we get going, all right? What's a scientific theory? And I get it, all right? I hear it all the time. It's just a theory. It doesn't mean anything. It's just a theory. It's not a fact. All right. In science, in order to become what's known as a scientific theory, it has to undergo so much testing it would break your brains. Okay. In order to be a theory, it has to be tested and tested and tested and tested, and that it's accepted as a acceptable theory. Now, when it's a theory, it means it's been tested by hundreds, usually, of people, thousands of people in that specific field, and they have yet to find that the experiment has yielded anything but the original. So if the theory is, if I drop my wallet, it will fall, okay? So we'll make that a scientific theory. It would mean every teacher in the building has dropped my wallet and it fell, and it's done that every single time. If for some reason they drop it and it doesn't fall, it floats away, does whatever, my theory is rejected and is no longer accepted, and we get rid of it, okay? Science is always trying to update itself. That's the best part about it. We are always open to improve our understandings of things. Theories are theories, okay? But they can always be updated and changed with new information provided. So, some of the big ones, this is my man Einstein, right? Einstein came up with the theory of relativity. It's about speed and everything else. It's E equals mc squared. It's a physics theory, okay? The big one that everybody knows, the theory of evolution. Now, my man Charles Darwin, who's one of my favorite scientists of all time, okay, proposed the theory of evolution. What that theory states is that the fitter animals for their environment survive and are able to pass along their genes, okay? And that those animals then inherit those characteristics in its offspring. But other things that are theories, guys, all right, are things like the theory of gravity. Gravity still has parts of it that is theoretical. What? What? So anytime somebody goes, oh, I don't believe in that because it's just a theory, ask them if they want to go jump off a house and test the theory of gravity, because you're arguing the same thing. They've both been tested religiously and so much, and yet to be proven wrong. Okay? Those are theories. They are not your common everyday, like, I have a theory that these two kids are dating. That's not a scientific theory. A scientific theory is something that has been tested repeatedly and repeatedly and repeatedly and repeatedly and repeatedly. You get my point. And has not been proven wrong. So we accepted theories in science class, okay? That's where we're going to roll with it. So the theory of evolution is an accepted theory. All right. My big joke that I've always said is the theory of evolution is still the theory because it's still evolving and changing. Bad dad jokes. You're welcome. Scientific laws, on the other hand, are super duper solidified. Typically, the difference between a theory and a law is that laws have the math to back them up. They have the math to say this is going to happen every single time, and we can prove it that it will never, ever, ever change. Laws can't change. Okay? That's what makes them harder. In fact, in science class, we usually go more down towards theories because we're always trying to update our information and always trying to change these theories. We're always trying to get more information and update it so it's as accurate as possible. Now, laws, on the other hand, don't get updated. They don't get changed because once it's a law, and it's there. All right? That, my man, is Isaac Newton on our screen. Isaac Newton, brilliant dude. Okay? Like, legitimately. So he was a C to D average student in his college. College went on break for 4 months, for some war or outbreak. I don't know, because it was ancient England. Now, Newton, you all know the story, apple fell on his head and he was like, oh. And he started creating a theory of gravity and the laws that came along with it. But not only did he do that because it was originally a theory, the way he got the math for it is he also invented calculus. My man not only came up with the laws of gravity, but he came up with calculus to prove and turn his theory into the law that it is today. Imagine that. And it was in like 3 to 4 months he did this. He came up with one of the most fundamental and most important laws in science class. And then he came up with the math to back it up. And then not only law of gravity, but he created the field of calculus study. Now next, the Dark Ages. And this is where we get into some problem at. The Dark Ages were where religious groups controlled everything. Okay, you guys will learn more about this in world history, maybe 1, more than likely 2 though. I don't remember where it ends. But Dark Ages, right? The church ruled everything. And the church's word was law. If you went against it or you tried to improve it, you were exiled or killed or murdered. None of those are good results. So, our boy Galileo, all right, who said, hey, maybe we as the earth kind of circle the sun. Just saying. What did they do to him? Which we all now know is accurate, right? We go under the heliocentric model in our solar system, which is that the planets orbit the sun. He was the one to propose that idea. Crazy, right? Everybody knows that the earth revolves around the sun. Now, when he did it, the church exiled him. They kept him under house arrest where he started to starve and he ended up dying. All because he said that the earth was not the center of the universe, which went against biblical teachings at the time. So science used to be a dangerous field. If you said anything that questioned any part of the church or religion, you could be heavily, and more often were always heavily persecuted and executed. All right, Charles Darwin, the reason he took so long to write his theory of evolution is that his wife was devoutly religious, and he knew that once he proposed the theory and once he published his results, that it was going to lead to a disaster. This is the mid-1800s, mind you. All right, this is not that long ago. He did, and what ended up happening is his whole family was exiled from the church. The reason he took so long is because he knew the repercussions he was going to face. He knew how his family was going to be bullied and picked on and exiled and sent away because he himself came up with the theory of evolution and proposed that. It's crazy to think about that. Finding out research and information and helping make the world a smarter and brighter and more intelligent place used to get you in so much trouble and could get you potentially killed. All right, in the Renaissance period, though, this is when we started to go, hey, you know what? I like this thinking thing. This guy's smart. Let's roll with his stuff. All right, we started to re-emerge into all these sciences. This is where philosophies came from. This is where psychology started to come around. All right, this is where we got to these ideas and we were like, you know what? Let's go on this. And that guy right there is Francis Bacon. He is credited with devising and coming up with our scientific method. This whole unit has been about. All right. So that's been where we're at. These are some famous scientists right here. All right. Sir Robert Hooke came up with the cell theory. Sir Isaac Newton, gravity. Louis Pasteur came up with pasteurization, all right, which you might know in milk, but it basically allowed us to make our first antibiotics. Johannes Kepler calculated the mathematical laws of orbits, and Robert Boyle came up with the laws of gases. It's crazy. All right, people are incredibly smart. I will go over more and more sciences as we get further and further along in the year, because I'm a big believer that we got to kind of look at some of our past. We got to honor and remember these incredible individuals that made such profound discoveries and realizations when there was nothing. Right? Like, to come up with something new and to invent and to create and then to back it up and then to provide the evidence to back it up is just, it blows my mind. So hopefully you guys have learned a decent amount from these PowerPoints, these 3 parts of the videos. If you're good, you're good. If you got any questions, you know what to do.